Now we have to discuss. In the previous lecture, we take the discussion of basic property of the charges. In the previous lecture, we discussed only three properties. The first properties we have to discuss from a positive charge, electric field lines are originated from the charge and terminated at the infinity. And second property we have to discuss from a negative charge, the electric field lines are terminated and originate at the infinity. And now we have to discuss the third basic property here. If here are the electric fields, if here are the electric fields like that, and here electric field is like that, electric field is like that. What conclusion from seeing the electric field from here and from here? Here we concluded that here is the electric field is E and here is the electric field is E. Here we see that the spacing between the two field lines is equal. Here the spacing between the two field lines are equal, and this is called uniform electric field. Uniform electric field lines. If the spacing between the two electric field lines is constant throughout, then we can say that the electric field is uniform in nature. And here we see that the gapping between the two electric field lines is decreases continuously, and this nature of the electric field lines is called that non-uniform electric field lines. Now another result is coming here. If we have taken the 2 points here, one point is here A and another point is taken here. From these conclusions we have seen that the electric field at A is lesser quantity. Electric field at A is lesser as compared to electric field. How we can conclude it here? Here we have to conclude that here the field lines are very far. The intensity of the electric field lines is also lesser, and here the electric field lines are very closer. The electric field lines, electric field intensity is more. Electric field intensity is more here, and electric field intensity is lesser here. The result is coming from here. If the electric field lines are very closer, the intensity is also more. Here we have to conclude that if more closer electric field lines, then intensity will be more. This is the important factors. From here we have to conclude that this is uniform electric field because the gapping between the two electric field lines is always constant, and this is a uniform electric field. If we are seeing here this type of electric field is called non-uniform electric field lines, and here we see that this is the point A and this is the point B, and we see that the electric field lines are very far from here, then we see that electric field is lesser at A quantity and electric field and more as B point. Now next property is coming here, intersect each other. The next basic property, fourth basic property, fourth, two electric field lines does not intersect each other. This is a very important property. Two electric field lines never intersect each other. If we see that there are two electric field lines, these are the two electric field lines. Suppose we have to assume that the two electric field lines are intersecting each other, and here we see that this is the point of intersection. and electric field lines are going from here and electric field lines are coming from here. This is the first electric field and this is the second electric lines. If we see, this is the point of intersection. If the point of intersection is here, if we draw a tangent on this curve, the direction of the electric field is here, because electric field lines is imaginary lines, and if any curve is given, if we are draw the tangent at that point and the tangent shows the direction of the electric field. Here this is the electric field given at this point O. Now this is the another curve, and draw the electric field line, the direction of the electric field lines, and draw the tangent line here, and this shows the direction of the electric field lines at P2. But the point of intersection is same for both the electric field lines at a single point. At a single point, two direction of electric field is never possible, and this is the problem, and hence we can conclude that two electric field lines never intersect each other. This is the important basic concept. Two electric field lines does not intersect each other because at the point of intersection, two tangents are drawn, and two direction of electric field line is represented. That is never possible. At single point of intersection. These are the important properties, so we have to remember. The previous property says that if the field lines is closer, the more intensity of the electric field lines. If the field lines is far from each other, then lesser electric field lines intensity will be here. Next important property is that two electric field lines does not intersect each other, because as the point of intersection, two tangents are drawn on the curve, and which shows the two direction of electric field. At a single point, two direction cannot be possible, and this is not possible.